All right, so today we're talking about linear programming, which is basically a topic inside of linear graphs. Now, this here is going to involve what we call inequalities, and we'll have to find a region that we would call a feasible region to basically see if we have variables, how do we optimize the use of these variables with particular restrictions. So this is going to take into consideration the concept of linear graphs that we've been doing, the y-intercept, x-intercept, and so forth. And once we get to go with it and understand what's happening, you guys will see how it all connects. Okay, so the objectives we're going to have, we want to identify the feasible region of a linear programming model. We want to be able to calculate the optimized solution of a linear program. What is linear programming? So if you look at this, we have three different lines that come together to form what we call a linear program. Now in this shaded region, the blue region, we call that the feasible region. Okay, so inside of this feasible region, we have feasible solutions. So these feasible solutions basically mean that they are ones that meet all the constraints. So think of these lines here as constraints. So we'll get into discussing what they are, how to develop them, how to draw them, and so forth. But generally, when we bring these inequalities together, the region that is shaded is called a feasible region, and inside that would be the feasible solutions. Now these points are going to be the points that we are most concerned about, because they will tell us what would be the best way to optimize any solution related to this. Anything outside of this region is considered infeasible. So we're going to talk about that as we get along. So for now, even though this may or may not make sense, as we advance into the topic and it starts to digest, everything will start to make more sense. The first thing, we know that this is a mathematical technique that uses inequalities to find optimized solutions. So in this case, we had two variables, beer and ale. So these two were the limited resources that we were looking at. So we're trying to find the best outcome for the allocation of these resources. All right, so when we're done with all of this information, usually we have a formula that either is a profit or something that gives us an idea as to whether we are making maximum use of it or we are minimizing expenses or whatever the case may be. All right, so take this down, and then after we'll start to get into it. All right, so these are the basic terms that we usually use in linear programming. So we have the decision variables, right? So there's a limited resources that are being assessed. So for instance, in our example before, it could have been the beer and ale. So in essence, when you're basically comparing x and y, you say that the x and y's are the variables. It could be the a and b, whatever letters you decide to use. And the constraints would be the restrictions on those resources. So for instance, let's just imagine x represented bananas and y represented mangoes. Or better yet, let's say B represents bananas, and M represents mangoes. Now, those are your decision variables, are your limited resources. Now, just imagine your mom tells you to go in a shop and you could only buy 7 of those fruits. Okay, so those 7 fruits that you could buy must include mangoes and bananas, but 7 is a restriction. So you can get 7, maybe less than 7, but can't get more than 7, because she says she don't want you to get more than 7 fruits. So if you have 7, you could get 6, 5, 4, 3, 2, 1 straight down, right? So the whole point is that that is a constraint. Okay, now when we talk about the objective function, maybe you want to eventually sell those fruits for some form of profit. All right, so if you're trying to sell for some form of profit, that would be your objective function, because your main point for analyzing these resources and analyzing these constraints is to figure out what you could do to either maximize the profits or minimize the costs. Okay, and the feasible region is just the area that I showed you earlier with all the feasible solutions. So basically that will tell you the region where it's safe to meet all the constraints. So in essence, that's like your safety zone, that's like your safety net that meets all the constraints for the decision variables. All right, so that's the theory behind it. What we would actually be doing is the actual calculation part of it to better see and understand what is taking place. All right, so this right here is an example of what we're going to be doing, right? So looking at this right now, it may not make sense to you, but by the time you're finished, you should be able to understand what's going on here. So as you can see here, what do we call this blue section shaded here? What do you think this is?
Feasible solution.
So that's a feasible region that has a feasible solution. And then this part here represents the constraints. So as you can see, it says 2 of x plus 3y is less than or equal to 9. So that's a constraint here, the less than or equal to 9. It's telling me cannot be more than 9. X is more than or equal to 1. So this is also a constraint. It's telling me it has to be more than or equal to 1. These here are considered to be constraints. And the decision variables would be x and y. So as you can see here, x and y represents the decision variables. These inequalities here represent the constraints. So this represents the constraints. Inside here represents the feasible region where we find the feasible solutions. Now this here that says profit is equal to 7x plus 8y, that's our objective function. So once we figure out what the points are that we're going to use, we're going to put them in this objective function to see which one gives us the best answer. So understanding how inequalities are shaded, that's the first thing we need to do. So the first thing, when x is more than the equation, we shade the right of the graph. So if you look at this here now, x is more than or equal to 1. Tell me some numbers that would be x is more than or equal to 1.
1, 2, 3, 4.
Excellent. 1, 2, 3, 4, and so forth, right? So that's why we look at x here, which is 1 on the x-axis. So we come down here. This is the 1 right here. And we are shading in the area that's going to be more than or equal to 1. So this whole section here is more than or equal to 1. Okay, so x is equal to 1 right here. Okay, so that's why we shade this side to the right of this line. And notice this is a solid line. So we usually use a solid line when we have the equal to part underneath. So make sure y'all write this down and draw this because it's going to be important to understanding this. So this is one of the things that when I was learning this, if someone explained this to me, it would have made it so much easier to understand. But once you learn this part, it helps a lot. Alright, so when x is less than the equation, we shade the left of the graph. We shade the left of the graph. So as you can see here, x is less than 2. Now notice how we have this in broken line. Unlike the other one before, it was a solid line. This one here uses a dotted line because it does not have the equalish part, the equal part underneath it. So numbers that are less than 2 will be numbers like 1, 0, -1, -2, -3, -4, and so forth, which is why this region here is shaded blue to represent the section that is less than 2. Alright, so take this down. Alright, so this one says when y is less than the equation, we shade the bottom of the graph. So if you think of it, right, now that we are on y, this is the y-axis, so we look for the 2 on the y-axis, which is straight across here, as you can see. Okay, so the y here is 2, so anything less than 2 is what we're going to shade because it's under. So on the y-axis, so y is less than 2 would be numbers less than 2, so 1, 0, -1, and so forth. Okay, so that's what we are referring to when we say y is less than the equation. We shade the bottom of the graph. So we're looking at this line formed on the graph, and then we shade underneath it. All right, so bearing that in mind, what do you think we would do if it says y is more than?
Shade the numbers above too.
We would shade the numbers above. Excellent. All right, so take this down. Then after we look at the next part. When y is more than the equation, we shade the top of the graph. So if you look at this graph here, the line for y -2 is right here. So what we would have to do in that case is shade above it. So that's why you see in this case, we say y is more than -2, we shade above here. All right, so take this down, and then after we get into some other stuff. All right, so shading inequalities with 2 variables now. So looking at this here now, right, this is how I read it. I always focus on the y. I always focus on the y. Okay, now the reason why I focus on the y, because when it comes to y, we're looking at either up or down, below or above the graph. So if I'm reading this, this says y is what? Y is, what does this sign say in relation to the y? This sign is more than when you're reading it this way. So it says y is more than x plus 1. So I'm just curious about the y part. So y is more than. I don't care about this x plus 1. This could have say 500x plus 10,000. Not my problem. All I care about right now is the fact that this says y is more than. When we're talking about y is more than, what section do we shade? Do we shade up or do we shade below the line? Do we shade above or below the line?
Above.
Above. Why?
Because y is more than the equation.
Why? Correct. Because y is more than the equation. For that particular instance, we would say that y is more than this equation here. So this is the equation here, this line here. Y is more than. Alright? Now, even if we were to arrange the equation so the 1 came over and its y is minus 1 is more than, I do not care about this minus 1. All I care about is y. So as far as I'm concerned, nothing else here exists, just y, and then I read in this part. So y is still more than. So that's what I'm looking for. And notice how it's a positive. So I'm keeping that energy. So y is more than, so that means I have to shade above. Now if you want to look at it from the perspective of the x, you have to go to x, then to the sign. So when you're reading here, this says x. Going towards here, it says less than. So x is less than, reading right to left. And when x is less than, what section do we shade? Left or right?
Left.
Excellent. So as you can see, this line, we're shading left of that line, all right, if you look at it from a perspective of x. But to avoid all of that confusion, I just look at it from y. I like to think of it as up and down. Simple. Makes life so much easier. Unless I have to use x, I'm gonna stick with y. So in this case, it says y is more than, so I'm shading above because it says y is more than. Even in this form of the equation, it's still saying y is more than. I don't care about this -1, neither does x. Now, this one here, what are we saying in this case? What is this equation saying as it relates to y?
Y is less than or equal to x plus 2.
Wonderful. But all I care about is going to be y is less than or equal to. So the fact that it says y is less than or equal to, I know I need to shade where? Above or below the line? Below the line. Excellent, because it says y is less than. Looking at this here too, it says y minus 2 is less than x. Still, all I'm concerned about is y is less than. Alright, does that make sense?
Yeah.
Lovely. Likewise, if we look at it from the perspective of the x, reading from right to left, because I need to look at what this inequality says. Reading right to left, what does this say about the x?
X is more than what?
X is more than, if we're going from right to left. Now, because it's x is more than, we shade to the right. Alright, so you see how it basically works out to be the same thing. That's why I focus just on y is less than or more than, so I can know whether to shade up or down. Alright, so we coming back here now. So as you can see here, I'm just showing you again what we looked at first. So the first thing we looked at was this graph and trying to understand what was going on. What did we say inside here was?
The feasible region.
The feasible region. Excellent. What did we refer to x and y as? What were x and y referred to as?
Variable.
The variables, the decision variables. And these inequalities that we see here, these inequalities, what do we refer to these as?
Constraints.
Constraints. Excellent. The constraints. Okay. Now, let me demonstrate what I was saying about the y part, right? So it says y is less than. So I'm looking at this. I don't care about this 3. All I care about is that y is less than this. Okay? So y is less than this. Alright, so y less than. So if y is less than, so this pink line here is basically that line that we're talking about shading less than. That's why you see it's shaded underneath that pink line. Okay, it's shaded underneath that pink line. And in this part here, it says y is less than the 4. Alright, so basically y is less than, that means I have to shade underneath this line, which is the x plus y full line. So as you can see, the green line here, we're shading underneath here. Okay, shading underneath there. And once we shade underneath here, that's under the green line. But notice if we shade under the pink line as well too, let's use a color close to magenta. All right, magenta. Okay, so is this here? But guys, can you see that it's starting to intersect? The two colors cross at some point. And the next restriction that we have is x is more than. So when it's x is more than, where do we shade? We shade to the right. Okay, so we shade to the right if it's more than. So then I'm shading to the right of this. And do you guys notice how it's actually intersecting? The three colors are in one area inside the blue area. So basically, when we are trying to combine all of these equations, we are basically trying to see where the shaded region would intersect. Okay, and it will intersect inside of this section here, because the red covers inside of here, pink covers inside of here, and then the red, it covers this portion here. So all this is where they all intersect. Okay, so we'll do a little bit more of that as we go along, but I'm just showing you as we build what we are actually trying to work out. Understanding how inequalities are sketched. So that's a very important thing to know as well too. So once we want to sketch, the two things that we need to find would be the x-intercept and the y-intercept. Alright, so usually for linear equations in the form ax plus by equals c, we try to find the x and y intercepts, and then once we find those x and y intercepts, we can connect them to draw a straight line. That's something that you're going to see in a bit. So in those cases, in order to find those, x need to be equal to 0 to find that particular y intercept, and then when y is equal to 0, that helps us to find the x intercept. So I know the part with the shading is a bit much, so as we go along this process, you'll start to put it all together. So we're gonna just focus on understanding what area to shade, which is what we did so far. But the next thing we want to focus on is how to actually draw the points. So I want you to take this down, then we'll go through it together. Remember we said earlier, in order to figure out what the x-intercept and y-intercepts are, we absolutely need to figure out when x is equal to 0 and when y is equal to 0. That's exactly what we would need to look at. So the first thing, let's say x is equal to 0. So we're going to be using this one here in particular for x plus y is less than or equal to 5. So how we write it is, we write it in the equation form. So x plus y is equal to 5, and we're going to do that when x is equal to 0. So we're doing that when x is equal to 0. So we have x plus y equal 5, x is equal to 0. So we substitute the x with 0, and we say 0 plus y is equal to 5, because we're basically trying to find a corresponding y value when x is equal to 0. Okay, so this is the equation that we're focusing on here. This is the first coordinate for the x that we need. We just need to find a y. So what's 0 plus y, guys? Y. So essentially in this case, y is equal to 5. So now I have a value for y and a value for x. Okay, so therefore my value for x is 0 and my value for y is 5. So I could say therefore that my coordinate here is 0, 5. And this coordinate represents the y-intercept. Okay, that's not as important as knowing that the coordinate itself that we're looking at is 0, 5. Now the next thing that we want to look at is when y now is equal to 0, and we're going to use it for the same equation, because remember, in order to draw the line, we need to find both the y-intercept and the x-intercept for both. So in this case now, I'm substituting the y equals 0 with y, so then I'll have x plus 0, because y is replaced by the 0, is equal to 5. So x plus 0 is x, so therefore x is equal to 5. Alright? So I know that when y is 0, x is 5. Likewise on this side, when x is 0, y is 5. So my coordinate is going to be x first, which is 5. And then after, my value for y is going to be 0. Alright? So therefore that's going to be the x-intercept. Okay, x-intercept. So I have 2 points already for this first inequality here. Okay, so let's try to put that in perspective. So I'm going to say that here is 0, 1, 2, 3, 4, 5, 6. We should do it a little bigger. So I'm going to skip every other one. So this is 1, skip that. 1, 2, 3, 4, 5, 6, 7. Do 8 for good measure. So 8. And then on the y-axis, this here is 0. So then we have 0, 1, 2, 3, 4, 5, and say, let's say up here is 6. All right. So what I need to do now, this portion here, these portions here, let's say they're green for now. So for these portions here, I need to plot them on a graph now. So 0, 5 is here. So that's right here. And then I now have 5, 0, which is 5, 0, which is right here. So for this particular one here, I can now draw the line because I have the y-intercept and the x-intercept. So therefore, from here to here, this right here gives me the line x plus y is equal to 5, right? So this represents that line. And because it says y is less than, where would be the shaded region? Above this line or below this line?
Below.
Below. Excellent. So I know that this here is x plus y equal 5. All right. So this one here now, x plus 4y is less than or equal to 8. So we're going to do the same principle. Nothing changes. So what do you think is the first thing we're going to do? We say x is equal to 0. That's the first thing we do. And then we substitute it in the equation. All right. So we say here x is equal to 0 again. And we're going to try that for this equation now. So we're going to say this is x equals 0. And we're doing it for the equation x plus 4y equal 8. So x is 0, so we substitute this x with 0. So then we get 0 plus 4y is equal to 8. Now, what's 0 plus 4y?
4y.
4y. So we'll end up with 4y is equal to 8. Now, how do you think we could get y by itself?
Divide by both sides by 4.
Excellent. So we divide both sides by 4. So then we're left with y is equal to 2. So then we have the coordinate for the y-intercept, which is 0, 2. Now, the next thing now we're going to do is what?
X-intercept.
The x-intercept, and what's the value of y in that case? 0.
0.
So then we could say x plus 4y again is equal to 8. Now, if I replace in the y with 0, I'll end up with x plus 4 times 0, because 4y is the same as saying 4 times y. So 4 times y is 4 times 0, which is equal to 8. So then I would have x plus 0 equal 8. So what do you think the value of x is? The value of x is 8. So now I have a value for y and a value for x. So my coordinate is going to be x, which is 8, comma 0. And this is the x-intercept. All right. So let's use another color for this one. All right. So 0, 2 is the first one. 0, 2. So 0, 2 for the y-intercept. And then we have 8, 0, which is the x-intercept, which is right here. All right. So then now we could draw our line. So straight across here, we drew our line. And we know that here's the y-axis. And over here is the x-axis. So as you can see now, we have this blue line. This magenta line and this green line. So those were the 2 points that we found for these lines here. Now, bearing that in mind, we say that x is more than 0. So x is more than 0 represents this line here. So when x is 0, we're referring to this line here, which ironically is the y-axis. So we're saying more than 0. So anything more than 0 must be to the right. So we're saying it's enclosed, it stops right here, so it does not go to any negative numbers. For the y is more than 0, more than or equal to 0, it says y, it does not go below this 0 line. So no negative numbers. So all this here tells us is that we're not looking at any negative numbers. We're just looking at the positive numbers because it's more than x and more than y. So you're saying x is more than or equal to 0, y is more than or equal to 0. All right. Now, based off of this equation here, these inequalities here, we can decide how to shade this. Remember, we say we focus on this, right? So I'm focusing either on up or down because I love y. All right, so focusing on this y here now. This y is telling us that y is less than or equal to 5. Less than or equal to 5. So I want to try a little something here. So less than or equal to 5 mean that this is where we're looking at, because I'm shading underneath the line because it's less than. Remember, when we are shading, when we say that y is less than, we're shading where on the line?
Below.
Below. Now, what I'm showing you is the breakdown that should be going on in your brain, okay? You don't have to do this when you're doing the question, right? I'm just showing you what should be going on in your brain. If you're saying, okay, y is less than 5, I need a shade under the line. So this is the line here that we had. I'm shading under the line. Now I have to do what for this line? I don't care about this 4 next to the y. I'm saying y is less than. I don't care about x plus 4. I don't care about none of this. I just care about the y and the inequalities sign. Okay, so this says y is less than. So underneath the pink line, where do we need to shade? Do we shade under the pink line or above the pink line? So for the pink line, we're looking at this y and we're looking at this right here. So it says here, in essence, y is less than or equal to, I don't care about this x plus 4, neither this 8. All I care about is the fact that it says y is less than. What portion would I be shading? Above or below the equation here?
Below.
Y below.
Because y is less than.
Excellent, because y is less than. So if I shade underneath here, okay, so I shade underneath here. All right, so this would be the section that is shaded. But remember, once it's all of these included, I'm looking for the intersection. Okay, I'm looking for where these two colors intersect. Can you guys see where the colors intersect? They kind of intersect where? In this dark region, right? So in essence, I showed you all of that to say that when I'm doing the shading for this graph, I need to shade where all the colors would intersect. So they would intersect in this section here, okay? So this section here in this particular question now represents my what? What does this section represent? Feasible region. All right, so I want y'all to take this down, and then we'll try a next one. Alright, so let's start going through this. So we look at the first part that says x plus 2y is less than or equal to 8. So for that one, we'll start off with x being equal to 0. So let's replace this x with 0. Once we do that, we'll have 0 plus 2y is equal to 8. Now if x is 0 that we have here, 0 plus 2y would leave us with 2y, which is equal to 8. Now to get the y by itself, we have to divide both sides by 2. So therefore I'll have y is equal to 8 divided by 2, which is 4. So when x is 0, y is equal to 4. Therefore our coordinate would be 0, 4. Now I have to do the same thing, but for this time I'll say x plus 2y is equal to 8 when y is equal to 0. So I'm going to say x now, and I'll say plus 2 times y, which means 2 times 0 in this case, since y is equal to 0, is equal to 8. Remember, x plus 2 times 0 is 0, because anything times 0 is 0, is equal to 8. So therefore, x is equal to 8. Alright, now with that being said, we know that coordinate has to be x first, which is 8, comma, 0. So then we have two coordinates already, 0, 4 and 8, 0, which would be for this first equation here. Now, I need to do the same concept for the second equation. So this was for this one here. Now remember, this equation which says equal is the line. This refers to the line that we have to draw. This here, as it is less than or equal to, represents the inequality. This represents the inequality which we have to shade. So this is a line, and this tells us where to shade relative to that line. Alright, so I'm doing the next one now. So it's gonna be for this guy here. So with that one, 3x plus 2y equal 12. So I'm walking out the line. That's when x is equal to 0. I substitute here now. So 3 times 0 plus 2y is equal to 12. So this is 0. So I'll be left with 0 plus 2y equal 12. So therefore I'll have 2y is equal to 12. Now to get the y by itself, we divide both sides by 2. So then I'll be left with y is equal to 6. So what would be my coordinate if I have x is equal to 0 and y is equal to 6? 0, 6. Now, I have to do this again, but this time I'm going to say that y is now equal to 0. Alright, so then I could substitute and say that 3x plus 2 times y, which is 0 in this case, is equal to 12. So 3x would be equal to 12 because basically 2 times 0 is 0. So divide both sides by 3. So then I'll get x is equal to 12 divided by 3, which is 4. So I have a value for x and I also have a value for y. So therefore I have 4, 0. Alright, so 4, 0. So I have two coordinates. So now I can actually put this on a graph and try to sketch them. So for the blue one, so 0, 4 is for this first line, 0, 4, which is a y-intercept. So 0, 4 is right here. And then we have 8, 0. So 8, 0 is over here. So from here to here represents that particular line, which is x plus 2y equal to 8. So remember, that's the name of the line. Where I have to shade would be what this tells me. Okay, so now the next thing now, 3x plus 2y is less than 12. So we have two coordinates for the 0, 6 and 4, 0. So 0, 6 is here, and then we have 4, 0, which is over here. So then now, in that case, what we have to do is connect those two dots, and essentially that's what we have here. So this here now represents 3x plus 2y equal 12. Now, based on these two graphs, where would we be shading? Do you guys know where we would be shading? If I was to shade here, below, because it says y here is less than. Remember, all I care about is this part. Y is less than. So for this first one, I'm shading underneath here. I'm shading underneath here. For this one, it's also y is less than or equal to, less than or equal to. So that means I'm shading again under this black line now. Now, when I try to think of shading under these two lines, they both intersect in this area here. So this here is my what region?
The feasible region.
The feasible region. Okay, now breaking on from this question, we're going to continue from this question going into the part that talks about the objective function. All right, so I'm going to use this to break down the concept of objective function as well. So we have our constraints here, and we have our variables x and y. All right, so this is our y-axis, and we have over here our x-axis. Now remember, guys, when it comes to the objective function, we use the vertices of the feasible region to determine the optimal solution of the objective function. So in this case, let's say that our objective function was us working out the profit, and the equation for that was 12x plus 15y. 12x plus 15y. So that's our objective function. So the first thing we need to do is list our vertices. Our vertices. Now, the vertices are basically the points that close the feasible region. So in the feasible region, the points that we considered would be here, 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 and here. So guys, can you see how this is enclosed by this shape here? This region is enclosed by these vertices. Y'all can see that? So then I need to list my vertices. So tell me, what are my vertices?
0.
0, 0. What's the next one?
0, 4.
We have 0, 4. What else do we have?
2, 3.
We have 2, 3. And what's the last one?
4, 0.
4, 0. Now we have the vertices. Now we need to figure out which one of these points would give us the highest profit. Alright? Which one of these points would give us the highest profit? So in order to do that, we have to substitute it in the equation here. Alright? So I'm gonna do the first one for you guys. I'm gonna do the first two for you guys, and then you guys gonna do the rest, and we'll go through them together. So profit for 0, 0. So obviously, if we're looking for the profit, we're looking for the maximum profit. If we were trying to save costs, we would look for the lowest. But since we are looking for profit, we want the most. So in this case, that means x is equal to 0 and y is equal to 0. So now I could use this equation here, 12x plus 15y. So 12 times 0, because x is 0, plus 15 times 0 is equal to the profit. So this would be equal to the profit. So this is 0 now, plus 0, which is equal to $0. Alright, so let's try the next one. So profit again, but for this time, we're going to use it when it's 0, 4. So for the same equation, we know that x is equal to 0 and y is equal to 4. So I can say 12x plus 15y. I replace this x with 0, so I'll have 12 times 0 plus 15 times 4. So 12 times 0 is 0, plus 15 times 4, which is 60. So then we end up with $60. So let's see what y'all would get if y'all do the other two. Then we'll know which one is the optimum solution. So remember, this piece here is a feasible region. So we're saying the best chance we have at getting the highest profit lies on one of these vertices. Essentially, we learn how to sketch the graph, then we learn how to shade the graph, and then we look at what would be the optimum solution. All right, we look like we got it. So let's go through them. So then we have the next one. So profit for 2 to 3. So then I could say that x is equal to 2 and then y is equal to 3. So then I'll say 12x. In this case, I'll say 12 times 2 because that represents 12x plus 15 times 3, which is y. So 12 times 2, 24, plus 15 times 3, 45. When I add those together, I get $69. So $69 would be our answer. Now let's look at the last one before we finalize which one is a winner. So we have profit, which is 40 now. So then we'll end up saying x is equal to 4, y is equal to 0. So then we'll say 12 times 4 plus 15 times 0. So 12 times 4 is 48 plus 15 times 0, which is 0. That's basically equal to 48. So our highest value, as you can see from these four, would be this one here. Okay, so therefore our optimum solution would be when 2 is 3, when x is 2 and y is 3. Okay, so the optimal solution is when x is equal to 2 and y is equal to 3. As you can see, this is this particular point right here. So this here is the optimum solution in this particular case. All right, does that make sense to you guys?
Yeah.
Wonderful, wonderful. All right.